you ever wondered why different colors seems to have different levels of energy? In this video, we will explore the hierarchy of color in relation to energy and discover how each color connects to different wavelengths and energy levels of electromagnetic spectrum. Before we start, let's test your knowledge about today's topic by having you answer these questions. Good day everyone, I am your teacher, Rica, and today I will discuss our topic entitled Color Hierarchy in Relation to Energy in Physics. Have you ever noticed that some colors are stronger than others? In physics, colors are not only used as art and design, colors are usually form of light energy. Today, we will learn how colors are connected to wavelength, frequency, and energy. We will also learn why some colors are stronger than others. Color hierarchy means arranging all colors based on their energy levels. In physics, colors are part of visible light. Different colors have different wavelength and frequency, and this affects the amount of energy they carry. When white light passes through a triangular prism, the light separates into different colors. This process is what we call dispersion. The colors we see are the colors found in a rainbow, which are RGB and stands for R for red, O for orange, Y for yellow, G for green, B for blue, I for indigo, and lastly V for violet. These colors are form of visible light spectrum. As we all know, visible light spectrum is the group of colors that our human eyes can see. These colors are arranged according to the wavelength and energy. Now here's the important part. Not all colors have the same energy. Red light has the longest wavelength and lowest energy, while violet light has the shortest wavelength and the highest energy. This means that as the wavelength becomes shorter, the energy becomes greater. To further understand colors hierarchy, let's talk about electromagnetic waves and energy. Before we talk more about colors and energy, first we need to understand where visible light spectrum belongs to electromagnetic spectrum. The electromagnetic spectrum is the complete range of all electromagnetic waves. These waves travel through space and carry energy. This spectrum includes radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma rays. These waves are arranged according to wavelength, frequency, and energy. Radio waves has the longest wavelength and the lowest energy, while gamma rays has the shortest wavelength and the highest energy. Visible light, which colors we can see, is only a small part of the electromagnetic spectrum. Even though it is small, visible light is important because this allows us to see colors and objects around us. Now that we understand the relationship between wavelength and energy, let us now proceed to the formula scientists use to explain this. In physics, wavelength and energy are connected. Long wavelength carry shorter energy and short wavelength carry higher energy. For example, red light has low energy because it has a longer wavelength. Another example, violet light has the higher energy because it has the shorter wavelength. Now that we understand the relationship between wavelength and energy, let us now proceed to the formula scientists use to explain this. The energy of life can be explained using this formula. E for energy, H for Planck's constant, and F for frequency. This formula tells us when frequency increases, energy also increases. Studying colors and light is important because it helps us understand how light behaves. Physics explains that colors are not just only for decoration or art. Colors are form of energy that affects technology, science, and everyday life. And that ends our discussion about the color hierarchy in relation to energy in physics. Thank you everyone for listening and participating. Once again, I am Teacher Rica, and this has been my presentation about color hierarchy in relation to energy in physics.